Hello everyone. In this lecture, I want to discuss non-exact differential equation. So, in the previous lecture, we also discussed non-exact differential equation, but we are doing many parts, types. Okay. So, in the last lecture, we have done type 2. So, here I am doing type third. So type third is also similar to type second, but here is difference is that del m upon del y minus del n upon del x divided by m. That in types in the type second there was here was n and this function was only x. Here is the function of y, and integrating will be e to the power minus g into g of function y dy will be an integrating factor, and we have a given first order differential equation, and then we will multiply by the integrating factor to the whole differential equation. Then this differential equation will become non-exact to exact, and then we can find the similarly solution of a given first order differential equation. So I want to discuss before going to one thing is that um, in the type third is a differential equation in this format, that is basically m dx, and that is equal to n f1, where f1 xy and f2 xy are two functions. Okay, so integrating factor will be 1 upon mx minus ny, where mx minus ny does not equal to 0. So this is also in a type for finding the integrating factor to be in a exact differential equation. Okay, so first of all I will also discuss what we are doing here up to. So let us suppose that we have this type of differential equation. So first of all we will check that this given differential equation exact or non-exact. Okay, so we have already seen that what is the condition to be checking given differential equation is exact or not exact. Okay, so if exact, then we can find directly the solutions. These things also we have seen. If non-exact, then we will find the integrating factor. Okay, so for finding the integrating factor we have many types of method. So we have discussed in the type first, so type second, type third, type fourth. Okay, so we have discussed many more in the previous lecture we have already discussed. So in this lecture I will discuss this type, f1 xy into y dx plus f2 xy x dy. Integrating factor will be 1 upon x minus ny, then when mx minus ny does not equal to 0. Okay, so for after finding the integrating factor, this is the integrating factor. If we will multiply this integrating factor by the whole differential equation 0, so it will become an exact differential equation. After making the exact differential equation, so we can find the solution of a given differential equation. Okay, so I will discuss one example, then after we will further see. So example is that xy sin xy plus cos xy y dx, xy sin xy minus xy into x dx. So this is whole the mx, and this is whole the n. Okay, so we can check that given this differential equation is exact or not. So I am saying here you can check that it is not exact. Okay, so I am writing here directly, but it is a non-exact differential equation. Okay, so I am finding the integrating factor with the help of this procedure 1 upon mx minus ny. So integrating factor will be if equal to 1 upon m into x minus ny. What is the m? M is this factor 1 upon, I am writing directly, we will multiply by here this is x, so I can multiply here xy. So we will multiply whole the differential equation by the xy, x square y square sin xy plus xy into cos xy. Okay, minus, if we will multiply by y, so here we will multiply to whole the differential to this factor n by xy, so ny, so it will be minus ny, so x square y square sin xy minus minus plus xy cos xy. Okay, so here we can see that these will be to cancel, and integrating factor will be 1 upon I equal to 1 upon these two will be these two terms will be add, so it will come 2xy cos xy, cos xy. Okay, now this is our integrating factor. Now we will multiply to whole the differential equation by this factor, so it will become an exact. Okay, so we will multiply if into our given differential equation is that xy sin xy cos y xy xy sin xy plus cos xy into y dx plus xy sin xy minus cos xy bracket into x into dy. Okay, equal to 0. Okay, so we will multiply by this factor 1 upon 2x to 1 upon 2xy into cos y to hold the differential equation. So here we can say that if we will multiply 1 upon 2xy into cos xy upon xy sin xy, we can also multiply by y inside the y square plus y cos xy dx, plus we will multiply by x to this factor, so it will become x square y sin xy minus x cos xy equal to 0. So now we will multiply by this, so it will become x to x cancel, y to y cancel, y tan xy by 2 plus y to y cancel, and it will become 1 upon 2x dx. Now we will multiply by this, so it will become x to x cancel, y to y cancel, 1 upon 2x tan xy, okay, minus cos y to x, cos y cancel, minus x to x cancel, minus 2y dy, sorry it is dy, so dy, okay, equal to 0. So now this differential equation will become an exact, this will become an exact after multiplying the integrating factor. So here we can also verify that this differential equation is exact. Okay, but here I am finding the general solution of given differential equation. So y as a constant into m dx plus free from x and dy. Okay, so here we will write what is m. Here our m will be update after multiplying the integrating factor. So here y will be work as a constant, so it will become y into 10xy by 2 plus 1 by 2 x dx plus n dy. So here we will see that the terms free from the x, so it will become 0. So free from x is only this term, so it will become minus 1 upon 2y dy equal to 0. Now we will do integrate. So y is as a constant, so y by 2. The integration of that 10x is log sec x, so it is xy upon y is in a constant, so 2y 2 is outside, plus 1 by 2 integration of x is log x minus 1 upon 2 log y equal to log c, where log c is in any constant. So we can, it will be cancelled, and 2 is also we can take common and multiply by this, so that will become an also constant. So it will be log sec xy plus log x minus log y equal to 2 log c. Okay, this is also in a constant, so it we can also write this log sec xy plus log x by y equal to, we can also write another constant that is equal to c dash. So here we can write log xy into sec xy equal to c dash. So we can also write xy into sec xy equal to e to the power c dash. This is also in another constant, so we can write x into a y upon sec xy, so we can also write a y cos xy. So this is the general solution of a given differential equation of the first order. So this was the procedure to solve a first order differential equation that was not exact. So in this lecture we basically did two types. Type third, in the type third we did we have a differential equation m dx plus n dy, and that differential equation is not exact, so then we will find the integrating factor. So this is the procedure to finding the integrating factor. Del m upon del y minus del n upon del x divided by m equal to gy, and integrating factor will be e to the power minus gy dy, and after multiplying the integrating factor to our original differential equation, that will become an exact, and then we can find the solution. Okay, in the next type we have done this type of the format of a given differential equation is that f1xy y into dx plus f2xy into x dy equal to 0. So integrating factor will be 1 upon x minus ny, but provided mx minus ny does not equal to 0. So this will be the integrating factor, and after finding the integrating factor we can multiply this integrating factor to our original given differential equation. So after multiplying this integrating factor, that differential equation will become a new differential equation. So we will find our m dash n dash, and then we can find the solution, general solution of a given differential equation. So in the next lecture we will do some more examples or some more types of finding the integrating factor. Okay, thanks.